This section provides an explanation of the OCTARVIA-web application. The OCTARVIA-web application has three calculation modes. Index mode, which calculates the index for the evaluation of ship performance in actual seas, prediction mode, which simulates actual operations, and simulation for fouling and aging effect mode, which simulates the increase in power output due to aging and fouling. There are three calculation functions in index mode. The first is a calculation function that estimates the effects of external forces, such as waves, wind, drifting, and steering with ship data. The second is a function that uses the first external force calculation function to carry out a performance calculation and derive the ship speed and the fuel consumption. And the third is a function to calculate the life cycle fuel consumption of the main engine, which is an index for evaluating ship performance in actual seas. The calculations can be performed for each of these alone or combined and calculated simultaneously. In this case, all calculation items are selected. Select the calculation items, press the Data Input button, and move to the Data Input screen. The input screen is divided into a main input sheet and a sub-input sheet. The following section describes the inputs on the main input sheet. This is where you select the supposed route. The route can be selected from 6 representative routes and a worldwide route. The map display differs according to the route selected. The probability distribution of the weather conditions is set based on the statistical data of the weather conditions in the area marked on the map. Next is where the parameters for aging and fouling are entered. For aging, set the annual deterioration rate for hull resistance and specific fuel consumption rate. For fouling, set the annual deterioration rate for hull resistance and propeller efficiency. For hull and propeller, the cleaning interval and recovery rate during cleaning can also be set. The changes over time in the increase in hull resistance, the deterioration in propeller efficiency, and the deterioration in specific fuel consumption rate according to these settings are shown in a graph. Next, enter the data on the ship and the performance in a calm sea condition. Enter the data on the sub-input sheet. If the loading conditions are different for outbound and inbound, enter the data for each condition. In this case, the same settings are used for the return trip. Enter the data for the requirements and also enter the sectional data and the waterplane data on a separate sheet. Enter the draft, width, and cross-sectional area of the hull in 20 sections as sectional information. Enter the width data as waterplane shape data. Enter the performance in a calm sea condition separately for the resistance and self-propulsion elements. Return to the main input sheet. This is the input area for the main engine. The main engine information, such as MCR settings and specific fuel consumption rate, is entered on the engine sheet. On the main input sheet, the main engine operating conditions are set. The main engine operating conditions can be selected from constant speed, fuel index control, and constant power and constant speed. Here, according to the index calculation conditions, select constant ship speed and enter the ship speed. Finally, enter the propeller information in the sub-input sheet. Enter the particulars and characteristics of the propeller. This completes the data setup. Along with the input data, For whole form data and propeller data, it is possible to import the estimation results of Eagle OCT. For the performance in COM-C condition and main engine information, it is possible to import analysis results from Salvia OCT. When using these data, the calculations are ready once the operational conditions have been entered on the main input sheet. Click on the Calculation button, which can be found on the top screen or at the bottom of the main input sheet. Once the calculations are completed, the final output sheet is displayed. Here, changes over time in ship speed, fuel consumption, and cumulative fuel consumption are displayed, as well as the life cycle fuel consumption of the main engine, which is an index for evaluating the ship performance in actual seas. The changes over time facilitate the evaluation of maintenance plans, such as cleaning intervals. The life cycle fuel consumption of the main engine is calculated as a total value and an average value per day, which is both efficient and easily understood. In this way, it is possible to quantitatively present ship performance in actual seas in terms of parameters directly related to costs. Intermediate output includes power curves and short-term prediction results. Power curves are calculated for each variety of weather condition, enabling performance analysis for each weather condition, ship speed, and direction. Short-term predictions are also performed for each variety of weather condition, taking into account the estimated results of the power curve and the torque limit conditions of the main engine. As intermediate outputs, the added resistance in waves, wind resistance coefficients, resistance due to drifting, and the resistance due to steering are also calculated respectively and can be viewed via the link on the final output sheet. This concludes the description of the OCTARVIA web application.